In this video, we're going to continue our discussion regarding solutions. You may remember my first video in this unit just involved introducing what a solution is, talking about what kinds of solutions we have. We have gas-gas solutions, we have liquid-solid solutions, and we have solid-solid solutions. We talked about what the difference is between a concentrated solution and a dilute solution. What I want to do in this short clip here is just quickly refresh your memories regarding the differences among the terms unsaturated, saturated, and supersaturated. Once again, I have looked around the house and I've grabbed a few little chemicals. Some are food sources, and we're going to have a little fun with this. So remember, solubility is the quantity of solute that can dissolve in a solvent. We know from before in the course that certain substances are more soluble than others. We looked at our table and we could predict solubility based on that. Now we're going to quantify it a little bit more. The simplest solution that we can make is that dilute one, and really if you think about it, a dilute solution is really a very unsaturated solution because it can hold more solute. And that's the definition of an unsaturated solution. A solution that can dissolve more solute than it presently has. So for example, my quite dilute bit of food coloring here can hold more food coloring quite easily, and I could easily make it more concentrated. With a few drops of food coloring, you can see if I mix it, clearly it's not uniform at this point, but as soon as I mix that, it's more concentrated here than it is down here. I'm not going to mix this entirely, but you get the idea. So that would be unsaturated. A saturated solution is a solution that can't really hold any more solute. And of course, the best way to think about that is a sponge full of water. There's a limit to the amount of water you can put into a sponge if you dip it into a bucket of water. Well, it's no different in the world of chemistry. There's a limit to what we can dissolve. So very simply, I've got some sugar here, and I've got a beaker with a bit of water in it, and my stirring rod. If I put a little bit of sugar in this, and I attempt to dissolve it, it does dissolve quite well, right? Sucrose, which is table sugar, refined sugar, whatever you want to call it, is quite soluble in water. But interestingly, you get to a point where it's almost like the sponge that's full of water. When you get a lot of solute, in this case the sugar, added to the water, no matter how much I stir, there's going to be a little bit of extra salt, or in this case sugar I should say, at the bottom. And perhaps this solution has reached its saturation point, much like the sponge. So that's not that earth-shattering, but certainly helps us explain the difference between unsaturated and saturated. The final one is the most interesting in my opinion, and that's the supersaturated solution. This is a solution that we have to manipulate to create. And the two ways that we generally in the lab manipulate solutions is to A, change the temperature, or B, change the pressure. Well, I don't have a Bunsen burner here. I miss it deeply. But I do have my little itty-bitty can of Coke. And if you think about Coca-Cola, this is all sugar, of course, and water, but there's CO2 in here as well. That's what gives it the fizzy capability that we know Coke is so good at. And the CO2 combines with the water to make carbonic acid. In any case, this is under pressure. And we know that when you open a can of Coke, you relieve the pressure. Well, you may not have thought about it, but the CO2 is forced in here under pressure to the point where its concentration is higher than would normally be possible in an open glass. So when you open that can of Coke, like that, I'm not a big pop drinker, of course, it's not good for us, but we'll make an exception. Give ourselves a little treat. When you pour it, you can see the bubbles. Those are CO2 bubbles, and they are being released because they're no longer under the same pressure, and we had a supersaturated solution with CO2 in it. Ironically, it becomes saturated as the CO2 comes off, and probably unsaturated once it goes flat, because the amount of CO2 becomes less and less and less over time. No one wants to drink flat Coke. So that is the quick lesson to show us the difference between unsaturated solutions, solutions that can hold more solute, saturated solutions, like the sponge, can't hold any more. And finally, the supersaturated that we had a minute ago holds more than it should because it's under pressure. We can do the same thing with temperature by heating up a solid and getting more of it to dissolve inside. Chemical cold packs are good examples of those types of supersaturated solutions. The kind that you hit the little button and it heats up spontaneously. It's actually a chemical reaction. On that note, cheers everyone. I'm going to enjoy my sample of saturated CO2 outside of the can. Cheers.